Yes, good morning. Um, you're welcome to the Monday lecture. So I'll be rounding up on electronic workbench on the multi-sim, and I'll be uh, doing some little practical also. So we'll start right away, even though we have about few people. If you are not hearing me, please make sure you enable your microphone and join with microphone, join with voice so that you can hear. But don't talk during the lecture so that you will not uh, you will not um, interrupt the the class. Very much time. Okay, I will have to do most people as they enter because there'll be distraction. Yeah, I don't want distraction. Okay, as you can see, I'm recording also. Okay, I want to share my screen. Um, yeah, welcome to DC110 Computer Aided Design and Drafting for Diploma 1 Engineering class. This is the second semester, number one. Just want to encourage everyone to be very serious and make sure that you do your part.
Sinas is not like
Hello, the noise is much. What is happening? Please mute yourself when you come in so that I don't have to be worrying about muting people. Mute yourself when you come in. Only when you have question at the end of the class, you unmute yourself, okay? Okay, now we are starting immediately. I want to finish the, let me finish this lecture. So I expect you to have to make sure that you finish up your assignments, print them out. I want to see the faces of the instruments you use. Make sure that they appear in your printout. Okay. Um, These are things I'll be looking at today. Yeah, this is electronic workbench tutorial that we use for our lab manual. I've done a video on this, so try to go through them. And if you have any question, you can still contact me. And the other video I did for the Zener diode BZV49-C8V2. Now this is let me share it so that you can see. I need to share this. I need to share. I need to share this. Okay. I want to share my screen now. Yes. Now this is the data sheet of the of that Xenon that we could not get the data, but we have to use virtual Xenon diode, and we have to put 8.2 as the voltage, um, which will determine the characteristics, that is the parameters of the Xenon diode in operation. So anytime you have a component that you don't have the real component in the master database of our electronic workbench, so what you need to do is to just make sure that you try your best to use the virtual Xenon or virtual component of that, and from there you'll be able to get to that. So quickly, I will be I'll be doing a special lab stroke lecture on oscilloscope. So please make sure that you are following with me. You are following with me. Okay. I want to do the last figure 9, checking for the size of the ripple on the DC voltage. If you look at figure 8, it is using the oscillator to inspect various voltages in the circuit to make comparison between channels A and B. Uh, so let me quickly just, because from figure 8, from figure 8, I did figure 7, and then I did figure 8. So let me just recall figure 8. Let me recall figure 8 from recent circuit that I've said. So I don't need to start from the beginning. Okay. Okay, so let me share. Let me stop sharing. Let me share my screen again with this. Okay, I think we can see now. Well, we are coming up. That's okay. How many of you are around now? Okay, let's start. I'm recording, so I'll still put it on our YouTube channel so that for those who will not join on time, they can still watch it. Okay, now I'm trying to um, expand on the figure 8, trying to do some comparison. Okay, so we have used this Zener diode. After this has done the half wave rectification, that is this diode, then this capacitor 10 microfarad has done the filtering. Now we see another resistor here, and then we see uh, it may just be a limiting resistor. We have Zener diode here trying to regulate our output voltage to about 8.2 volts maximum here. And then this will be the load properly. This is 1 kilo ohm. Now we have put this. I'll put this. Amp, this is the oscilloscope screen. We have done all this setting here from the last um, from our last lab. Now I want to look at another thing. You see, this is we are trying to get the voltage at this point and at this point. Now, let me start all over again. So you can see this. So we want to see how we can adjust capacitor value so that we can see how constant this voltage will be. So we're trying to look at how adjusting capacitor value can. Uh, so what we're trying to do now is we're changing channel 8 to 5. Uh-huh. Now this is where we're trying to, and then we want to make sure that both the Y positions are set to 0. Now that is the adjustment we're trying to make here. I'm adjusting this to be 0 now. Can you see? Now this is what happens when that is done. So you are able to get that second figure 8 with the title using the oscilloscope to inspect various voltages in the circuit to make the comparison between channel A and B. So you can see how that is. Let me see if I can reduce this so that you can see the head. That is 5. Okay. Let me see if I can do this. Okay, so you can try this and see how it goes, how it looks like. This is like experimenting. You're in the lab, you can do a lot of experimenting. Um, so we have set both y position here to 0. I don't know, is it -0 I use? Let me see if I think it's 0 that I want to use. Aha. Yes, 0. Yeah. Okay. Uh, Probably I'll need to use 5. And this is also 5. Okay. And this I may have to use probably something higher. Okay. That's 5. I may have to enlarge. Let me see if I can move. Let me see if I can move the S position. Okay. Okay. Okay, this is okay. But let me pull this one down a bit and see how it goes. Yes. Let me also pull this one down a bit. Okay. Now, my objective is to make sure that you are able to see the top of it because of my setting here. So that is how the output will look like. Now, that is about that. Okay. Now, I want to take questions before I move to the last part. Or let me just do the last part so that you can ask your question together. Now, I want to look at figure 9. Just make a little adjustment to the circuit. Now, let me stop the let me stop the yeah let me stop the simulation. So you can see in figure 9, I am going to tie both channel A and B together. Let me show you so that you can actually see it. Let me share. Let me do a new share. Okay. Now this is the figure 9 I'm trying to do now. Let me just show you so that people can understand what I've been doing. We have been trying to work on oscilloscope. We have tried the exercises in the first lab, which you can see try to do. We have done this in the other video. Now this is what we have done last week. Then this is the figure 8 we are working on now, and we try to on the same figure 8 we try to do some adjustment, and we got this. Try to adjust the Y position and on both channel A and B, and we allowed this to come here. You can see the difference in the point from the point where we tap the channel A and channel B connection. Here you can see channel A is here, channel B is here. Now, if you see the figure 9, you will now see what we are talking about. So in figure 9, this is what figure 9. Another trigger is tapped from this end. So this is what we make it a little bit different. Now look at the figure here. The capacitor has been changed to 500 microfarad, whereas here it is just 10 microfarad, and the rest of the components seem to be the same.